Okay, so now we're going to look at a two-way chi-squared, but there's something I forgot to add into my one-way chi-square before I stopped the other video, which was I wanted to show you how to get the critical value without using a table, without looking up a table online or in your textbook. We can do that with Excel too. So there's a couple things that we need. It's actually one extra thing that we need. We have the other thing. We need alpha and we need our degrees of freedom. So I'm going to make a new user input right here for alpha. For right now, it's going to be 0.05. Oh, that was interesting. That it became green. I don't know why it did that. I'm okay with it, but not. All right, cool. So I'm going to insert my I didn't want that. Okay. So I'm going to insert the value that we're looking for right here. So this is going to be chi square critical value. And now that we have alpha, all we have to do is type enter chi square, and we want the one that is chi square dot inv dot rt. Now, essentially what this is going to do is this means we're doing the inverse of chi-square. So usually we're pulling a p-value out. That's the regular direction that we're getting the math. This way it's giving us the inverse of the formula, and so this is going to give us our critical value. So all we have to do is give it the probability, which is just Excel's way of saying alpha. So right here I'm going to type in B5, and now it wants to know the degrees of freedom, so we're going to type in B7. Hit enter, and our critical value is 7.81473. Okay. Do I still have my table up? No. Let's search for a table really quickly. Okay. It always takes, so much time. Okay. 0.05. 3 degrees of freedom. 7.815. Ours was 7.8147. So, rounds to the same thing. Let's make sure that we're right. What if we change alpha to 0.025 and our degrees of freedom to 11? Should be 21.92. Let's find out. .025, and our degrees of freedom is going to be 11. So we'll change n to 12, which makes our degrees of freedom 11. And our critical value is 21.92. So it's exactly what we want. Okay. I hit undo a couple times just to get back to where we were. It's got to look nice. There we go. Okay, critical value is now in red. Test statistic is in red. P-value in red down here. This is significant. This is, way larger than the critical value. The test statistic is way larger than the critical value. Here's your degrees of freedom. And we're good. One-way chi-square. Totally fancy. let's take a look at the two-way chi-square. The two-way chi-squared was a lot more difficult to to set up. There was some swearing, and I threw things, but I got it, so that's great. Um, we're gonna go through this, and I'll do it, you know, while you watch me build it, like usual. But I had to build it first, just so I'd have something to consult as I built it the second time. Just because it's, it takes a lot more steps than I initially thought it would. So, what I've got here is a 15 by 15 grid of user input. I don't think it's possible, but I don't think that you're ever going to run into a situation where you're going to have more than a two-way chi-squared with more than 15 groups. Either way, that seems it seems excessive. It's a lot of groups. So that's what we're going to start with. Is just this big field of green. In A1, I put observed just to, denote what's going on here. And then B2 through P16 is all user input, basically. This is where the actual values, your observed values, are going to be. So we're just going to recreate this down here. Yours, of course, can be in the top cells, the original cells where I have mine. So it's B through P. That's 15 letters. And then I'm going to jump down 15 here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. 12, 13, 14, 15. Okay. So I'm going to make these green now just so I know which rows I'm actually dealing with. The other thing of user input that you're going to need is just the rows and the columns. That's it. And then everything after that is formulas. So we're going to do n rows. You'll type it in here. N columns. You'll type it in here. So I put that one below n rows, n columns. Okay. Let's just totally make up a scenario where we've got 5 and 5, I guess. That's fun. So we'll do that. This is the user input you need. A couple things that we're going to have as our output. We're going to have the degrees of freedom. We're going to have the chi-squared test statistic. Actually, let's also do the chi-square critical value, the chi-square test statistic, and the p-value. Okay, so these are all the things we're going to want. Let's move this over. This is going to be red, this, and this, and this. Okay, we are ready to start doing some coding. Let's start with the easy one, just to ease ourselves in. It's cool. The formula for degrees of freedom for a two-way chi-square is rows minus 1 times columns minus 1. So the way that we're going to do this is we're going to do equals, open parenthesis, and we're going to do rows minus 1, cool, times, then we need a new open parenthesis here. We're going to go to columns, and we're going to say minus 1. Close your parentheses, hit enter. There we go. 16. Well, that makes sense. You just kind of check it in your head because 5 minus 1 is 4, and 4 times 4 is 16. Okay, yeah, the degrees of freedom are right. Get rid of that formula for now. Okay, now on to the crazy stuff. The first thing you're going to do is you are going to number the cells right here. You're just gonna in Q, you're gonna start at 2, and you're just gonna number down 2, 3, 4, 5, 6, all the way to 16, and then you're gonna start up here with 2, and you're gonna say 2, 3, 4, 5, 6, etc. Going along the top. I will explain why in a second. So really all you have to do is 2, 3, 4. Grab that, go to the fill handle right here, and we want to go to 16. Same thing going down, 2, 3, 4. Hey. 2, 3, 4. Let's grab it, and whoa. 16. All right, excellent. So what this group of cells is your basically your expected values, what you would expect to have here. And of course the way that we compute expected value for a two-way ANOVA is we multiply the row total by the column total and divide it by the overall total. If you want to see that written out as a formula, it is the row total times column total divided by overall total. Okay. So that seems simple enough, right? If we just had this data right here, it's really simple to do that. You just do 100 times 32 divided by 20, and that gives you 20. Well, actually, it doesn't give you 20, it gives you 16. But we want this to update based on the numbers we put in here. If we put in 5 and 5, like I have down below, we want it to automatically calculate the expected frequency in each cell. And it's not going to do that if we use cell F2 as the reference cell to figure this out every time, because that's just not where it's going to be every time. Okay, so how do we do it? Well, that's where these numbers come in right here. So the formula, yeah, this is a long and very crazy formula. So let's walk through it a little bit. What we've got here is we're going to ignore this if statement first. I just want to talk about this right here. So yeah, okay. Indirect. Did we use indirect in the other one? We did. We used indirect and address in the other one. It's okay. I don't have to re-explain it to you. You get it. Indirect is going to use the row column format for whatever is inside the parentheses following indirect. So it'll use that instead of actually using what you've typed in. So that's great. You can do some sort of operation inside of indirect. Excel's going to solve for the operation. And what you get out is what indirect is going to use to finish your mathematical phrase, whatever it is. Okay, that's indirect. Then address is a command that's going to give me the A1 style address of a cell that I'm specifying. So essentially, what I'm doing is I'm specifying a cell in row column format. Remember, row column format is going to be just numbers. I come up with the number of the row that I want to be in and the number of the column that I want to be in. For instance, usually we would call this row D3. But in row column format, it is row 3, column 1, 2, 3, 4. So it would be row 3, column 4, what we usually call D3. So if I type in row 3, column 4, it gives me D3. That's what address does. Hey, whoa. It's the wrong presentation. Okay. So that's what address does. Now, what is going on inside of address? Real crazy stuff. Okay, so what it's going to do is it's going to pull the number here that we've written all the way down the side to all the way to 16. Why? Because these actually correspond to the row numbers that we have here. So this is an easy way to reference the row that we're in. This is row 2, this is row 3, this is row 1 here, but we don't actually have any data in row 1 because we have these other numbers. So that's cool. That's what that's for. The numbers going across the top don't tell us what column we're in, because this is clearly not column 2, but they do tell us what column this piece of data is in. And so if I made a formula that said it was looking at Q2 where it says 2 and R1 where it says 2, and I did it in the address form, so I had the address point to Q2 and R1, then it would be address of row 2, column 2, which would then give me, row 2, column 2 would be B2, and then indirect would then reference what's in B2. So I could type all this crazy stuff in just for it to return to me 20. I hope that you followed that at least enough to see why we're doing what we're doing. Okay. So the row that we're in is this column of numbers right here. And to figure out the expected value here, I need to multiply this value, which is in the same row, by this value, which is in the column that this piece of data is in. Okay, so that's what this is doing. It's going to pull it from Q2 right here. But notice I've got a dollar sign in front of the Q. That means if I pulled the formula down or over, Q is going to stay the same. But the number does not have a dollar sign in front of it. That means the number is going to change. So as I pull the formula down, as I pull the formula to the right, Q does not change. And of course, 2 doesn't change because I'm just moving it to the right. We're still in row 2. But as I start to pull down on the formula, Q isn't going to change. We're still in the same column, but the numbers are going to change because there's not a dollar sign in front of them. So as I pull down on this formula, it's going to go to row 3. I keep pulling down. Now we're in row 10. I keep pulling down. We're in row 16. And essentially what happens is each and every one of these is going to move down and correspond to the row that it's in, Q3, Q4, Q5. So we're just pulling the row. That's what this is doing. So we know the row. Now we need to come up with the column that this piece of data is in. We need to know where the total is. Of course, it's in F2, but that's going to change if we put in something that has a different number of rows and columns. So that's where we get B19 plus 2. B19 is the number of columns, 4. Why is it plus 2? Well, because I burned a column right here with nothing in it because I wanted to write observed. So if we're heading somewhere over here, we're going to have to add 1 because I've used this column. So this is column 5. Remember, there's 1, 2, 3, 4 columns of actual data. I've burned one, so we say this is column 5. This is where the last piece of data is. But we want 100. The totals are in one more column over from the last piece of data. So then that's going to be 4 columns, 1, 2, 3, 4, plus 2, 1, 2, puts us in the 6th column. So 1, 2, 3, 4, 5, 6. And row 2, like we've been saying. And so that's right here at 100. So all of this right here is just referencing 100 multiplied by 32, right? So we're doing the same thing. B18 is the number of rows plus 2. Same deal's going on here. I've burned one at the top, and we actually want to go 1 beyond the number of rows we actually have because that's where the totals are. So instead of just 2, I actually need it to be 1, 2, 3, 4. And that's why we have B18 plus 2. Okay, so that was the row for 32. We now also need the column for 32. And you see that I've got this here as R1. R1 is 2. It's this group of numbers that we've got going across the top. And you can see that column 1, column 2. Column 2 is where we are, and that's where the total is that we need to multiply by the 100 that we just found. So this piece of the formula right here is just pulling out this single cell, 32. Now we have to divide it by the grand total. How do we find the grand total? Well, we kind of just take those two methods that we used, B18 plus 2 and B19 plus 2, and we add them together. We put both of those in the address indirect function. Why? Because, yes, we have 4 columns, but the grand total is in column 1, 2, 3, 4, 5, 6. And yes, we have 2 rows, but the grand total is in row 1, 2, 3, 4. So it's the number of columns plus 2, the number of rows plus 2. So if you just look at the math, we've got one big long address times another big long address divided by a third big long address. Okay, cool. And that's going to change based on when I move, when I pull on the fill handle right here and copy it for each and every column that's in this entire field. Okay, so what's going on over here? This is just saying that if any of these cells are blank, it's just going to show up as a NA, a cell that we don't want to use. That's why there's all these NAs right here. because I just marked them as cells I don't want to have to deal with later. When there's an NA, Excel won't do math on that cell. So if I put an NA in here, I can make a mistake up here and it won't try to take something from down here. So that's why NA is good. Okay. So we did a walkthrough of this code. I'm just going to take the easy way out and copy it, because I already came up with the code. So I'm going to put this code right here. Let's see, some of it has changed. We're going to need to change some of these because of where we are. Yours should be the same. Yours should be what's going on right here. Q2, B19, all these things. B2, B18, etc. That's what yours should be. Since I'm down here, I will change some of them. Well, first of all, I need to change these because I'm in a different place in the workbook. So this is 29, 30, and 31. The other one should be right because we're still in B. So this would be 1, 2, 3. Yeah, we're good there. Okay. So if B2 is empty, but I'm now using B29. So if B29 is empty, give it an A. Okay, so now we're going to do what's in Q2. Well, actually, now we need to do what's in Q29. This is just for me. Again, you are probably still following the one that I'm altering, the one with B2 and Q2. And then what's in B19 is going to be plus 2, but I'm going to use our new one, the number of columns, which is B46. Okay, next. B18 plus 2, it's actually now going to be B45. And that's not R1, it's R29. Oops, sorry about that. Because of where we are. And then again, these are going to be B45 and 46. A mistake was made. Oh no, a mistake was not made. There is no data in this. So let's put in a 25. Yeah, circular reference, okay. Oh, it's probably because we need some other data in here. So let's just throw in a 40 and a 70. Okay, what are all those added together? That's 95 plus 40, which is 135. And we're going to need something going on down here. Let's just do like something totally silly. 4, 4, 8, which is 16. This is 29. This is 44. This is 78. And the grand total is 151. Okay, and it still has a problem with it. Why? Oh, because I don't have rows and... No, I do have rows and columns in here. Oh, but it's the wrong rows and columns. So we had 1, 2, 3 columns, 2 rows and 3 columns. 2 rows and 3 columns. That did not help anything. Oh. R29 is incorrect. It should be R28. There we go. Great. So now that you've got yours, yours again should look like this, not the changes I've had to do here. You can click on this, drag it all the way over, and now click on this and drag it all the way down. All right, so now we've got, these are our expected values right here. And what we want to do is we want to actually compute the single unit chi-square. So that's just going to be observed minus expected squared over expected. Just like before. Not too bad. So we're going to do that here. Remember, we're going to do 2 parentheses. Observed divided by observed divided by expected, which is right here. Oh. I didn't put an equals sign, the thing that I'm always saying you have to do. Oh, man. Okay. And then a yawn. Sorry about that. Sorry, I'm like shoving the microphone down my throat while I'm yawning. Okay, so we're going to do observed minus expected. Let's close those parentheses. Let's square that. And now we have to divide by, what is it? This one or this one? It's this. Why would you do that to me, thing? It's this one. Observed minus expected squared over expected. And there we go, 25. So this one, you should be able to just grab, pull down, and pull over 15 letter units, basically. So 1, 2, 3, 4, 5, 6, 7, 8. There we go, 15. Okay, so there's the actual chi-squared values. These are the expected values. These are the observed. Okay, cool. So now the easy thing is we just have to compute the test statistic. And how do we do that? We add these numbers together. Not these or these, just these. We just add those together. And before we do that, let's get our critical value. So remember, that was equals chi-square dot inv dot rt. We need to know the probability, which, oh shoot, I didn't put in. It's going to have to be a user-defined column. We're going to put it in B47. B47. And the degrees of freedom are in B49. What? Oh, because I don't have anything in there. 0.05. That's our significance level. And we are also going to want to write alpha right there. And nobody needs to know this, but that has to be green. Okay, so there's our critical value. We want to put our test statistic in here, which of course is a sum, and we can say equals sum. And the first place we're going to start, we're always going to start in the same place for this sum, no matter what. It's always going to be this upper left corner, which is always going to be AH29. So we can start the sum with AH29 up here, equals sum AH29 through what? Well, we're going to have to do an indirect and an address formula again. So we're indirectly referencing the address form, and we need to know the row number. Well, the row number is going to change, right? So in this case, we've got 1, 2, 3 columns over and 1, 2 rows down. Remember, these are totals, and so are these. So it's really just these 6 cells that we need to take care of. What row are they going to go down to? Well, right now they go to 30, but that's not always the case. It needs to be the number of rows right here, 2, plus a constant that makes sense. So if we need to get down to 30, we're adding a number to 2. We're going to start at 28 always. So this address is going to be B45 plus 28. Okay. That was the row number. Now we need a column number. What we have in B46 for columns is 3, and we need to get all the way over here to AJ. So what are we adding to 3? Well, let's count back. We want to be here. We are going to count back 3. 1, 2, 3. So this is what we're going to add to, is right here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We stopped at the 8. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29 is E. 30, 31, 32, 33. So it's going to be 33 plus B46. Sorry, I just keep bumping my microphone. B46 plus 30. This is going to be an absolute value, and this is coming at them in row 1, column 1 style. Let's close the parentheses. Now we're back in indirect. It wants to know how are we getting it. Well, we're going to tell the address. Ooh. Sorry. We actually want this to come out to us in A1 style. Address always takes in things in row 1, column 1 style, but what it's asking for here is how should it output. And we want it in A1 style, so we should actually put a 1 here. Okay, so we have that. Now it's sending the A1 style to indirect, and we want, yes, that's the reference text. It wants to know if we want it in A1 format. We do. So in this case, we're going to type in true. And that should be good. Let's double check. AH29 through this one plus this one. Yeah, okay, that should be right. Okay, 26.82323. How can we double check that? Well, go over here, equals sum. Oh, I see my mistake. I actually accidentally added the wrong number here. So this is 15 plus here is 16, 17. Then we're going to add it to another 15, which is 32. 33 then is right here. And then we've got 1, 2, 3, which is the number that we're pulling from our number of rows. I have 30, it should be 33. There we go, 80.99, which is the same thing we've got here, 80.99. Fantastic. Okay, for the p-value, all we have to type in is equals chi-square dot test. We need the actual range and the expected range. And we're going to have to type in our code here again, too. So the actual range is always going to start on B29. For you, probably B2. But for me, it's always B29. And we can do the same thing that we did with sum here and go over columns and down rows with the chi-squared test. It doesn't all have to be in a column or a row. It can span both. So we're going to go B29. Since we're in B, it's not plus 33 and things like we saw before because we're here in B. We want to know the extent of where we go, so we're going to add, we want to go to 30 in the columns, or the rows, sorry. In rows we have 2, so it's going to be 28. That's just like it was before. We're going to do indirect address. The row number is number of rows, B45, plus, what did we say? 28. Our column is going to be, we're in column 1, 2, 3, 4. 4. And so then that means that our columns here are 3. It's going to be plus 1. So B46 plus 1. All right, indirect this and this. What comes next? We need to tell it that it's an absolute and that we want it in A1 style. Let's close that and that. Yeah. I'm going to close those two, and that is the end of our actual range. Now we need to do our expected range. Our expected range starts on R29 instead of B29. And now we can actually just copy everything we put here for indirect. And we're going to copy this information in here. That's not totally right. We have to change some things. What is right is the rows, which of course is, let's see, the first thing that's done is B45 plus 28. That is correct. But we have to do some changing to what we had to B46, which is the number of columns. So columns that we have are 3. We've got 15 in this green box, 16, 17. So it's going to be plus 17, basically. That's what we know from right there. It is in 18, 19, 20, but we want ours to be 17 plus the 3 from columns, or the number that changes as you update. All right, and there you go. There's the p-value. So we have the number of rows, number of columns, well, this whole data set, number of rows, number of columns, your alpha level as inputs, and as outputs you're going to get the degrees of freedom, the chi-squared critical value, and test statistic, and the p-value. I'm so sorry that that was a total headache, but that is just the only way I think that there is to do that. Okay, well, good luck making this. Believe it or not, I actually enjoyed getting it to work, but I think if you're a weird Excel person, maybe you think that, and most people are not weird Excel people, so I apologize. Okay, that is the two-way chi-squared test. I'll talk to you soon.